Okay, Assalamualaikum and really good morning to all of you. Okay, today we'll learn about the continuity of function and graph that we learned previously. So now we will continue our lecture with exponential function and logarithmic function. For exponential function, this is the form of exponential function, and from this exponential function where a is greater than 0, then a is not equal to 1 and x is any real number. And for this, we know that this is the exponential function, natural exponential function, which is at e is equal to 2.71828, which is e is also a type of number. And this exponential function e can be any number, which is 1, 2, 3, 4, 1 over 2, 3, any real number. Like we learned previously, real number is any number from infinity to infinity, but here it states that our a is only for a greater than 0. Okay, next is the value of when we want to find 2f2 from this equation, which is 3 power of 2, which is equal to 9. Then we have fx is equal to 3 power of x. When x is equal to negative 2, then we just replace negative 2, then if we get, okay, when power of negative 2, then it is actually this equation is 1 over 3 power of 2. Then okay, from this, okay, kita hilangkan negative power of negative 2 tu dengan meletakkan 3 kuasa 2 di denominator. Itu ialah dia punya rule. Okay, so next is the value of gx 0.5x. Then for x is equal to 4, just replace 0.5 power of 4. Okay, then we get 0.0625. Okay, this is the exponential function graph. Okay, then bentuk dia sama. Kalau 5 kuasa 1 ke, 5 kuasa 2 ke, 5 kuasa x ke, 6 kuasa x ke, eksponen kuasa x ke, dia akan bersilang dekat y sama juga dengan 1 ni, titik ni. Okay, so bentuk dia sama. Dia akan dapat satu graph increase macam tu. Okay, for this type of graph, we know that the domain from negative infinity until infinity, and the range is from 0 until infinity, and is not include 0 because of this graph will go downward tanpa cecah dekat titik kosong. Dia mungkin 0.01, 0.1, tapi dia tak mungkin cecah kosong. Okay, so now next is, okay, asymptote. Asymptote ni ialah bila y sama juga dengan kosong, iaitu ada satu garis di mana kita punya graf takkan lalu. Maksudnya ada satu garis kat situ, dia akan menghampiri garis ni tapi dia tak akan cecah dekat y sama dengan kosong. That's what we call asymptote. Okay, next is properties of exponential function. This is the properties. This is for graph of E kuasa X, bentuknya macam ni. Bila kuasa negatif X, dia akan reflect kepada graf yang ini, dia akan dapat bentuk yang ini. Then the domain same between these two graph, and also for the range is also same, and the intersection point here is still same. Then when this graph it increase, makin menaik, and for this graph it will decrease. Okay, this is the decreasing graph. Okay, so this is the x-axis, and asymptote is also the same. Yang kat sini dia x-axis ni akan jadi dia punya asymptote, and it's continuous for any area. Okay, dia selanjar pada semua tempat. Okay. For this graph, how to sketch the graph? Previously we learned about to sketch the graph. We first draw a table, then we find the nilai y dia, okey, daripada titik tu kita tahu kita dapat nilai y kita. So daripada nilai y ni kita akan dapat dia punya point ni, dan daripada point ni kita akan lukis titik-titik di sini dan kita plotkan graf kita. Nampak tak bentuk dia 2 kuasa X still sama dengan bentuk yang kita belajar mula-mula tadi. Dia akan dapat bentuk macam ni dan dia bersilang juga dekat 01 dan dia punya domain pun sama juga. Okay, so now for this type of 2 kuasa X, so now is 2 power of X minus 1. We know that when it is minus 1, this graph will going down sebanyak 1 unit. Maksudnya transformation of function. Kalau tak hafal transformation of function, please draw a table again. Okay, so now for this down 1 unit, then this is the previous graph, and for this gx, it will going down 1 unit, and this is our new gx. Okay, so and this is the new asymptote, and it will dia akan, maksudnya yang ni dia punya domain still sama, but for the range it is from -1 until infinity, dan tak termasuk -1 . So for this, okay, 2 power of negative x, we know that previously just now yang kalau kuasa negative x dia akan reflect, dia akan maksudnya dia punya corak tu akan terbalik . Okay, this is the previous yang kita ada 2 kuasa x tu, dan 2 kuasa negative x ni akan dapat satu corak yang terbalik, which is yang ni kan. Okay, so now the domain is negative infinity infinity, then the range is also the same 0 until infinity. So this is the rule for exponential function, which is b power of 0 is equal to 1. Any number when it is power of 0 and we get 1, then any number if it is power of 1 will get b. So then now for the rule of exponential function, we know that b log b x and we'll get x. Okay, so b power of xy and we get x times y. Okay, ini ialah rule yang kita akan guna sepanjang kita jawab soalan exponential function. Ini ialah bila dia bahagi x tolak y, bila dia satu kuasa negatif, dia akan dapat 1 per b kuasa x. Yang ni yang slide yang awal-awal tadi kan, yang 1 per 3 kuasa 2 tu kan. Okay, so yang ni ialah untuk b power of 3 per x. Okay, dia akan dapat b kuasa x punca kuasa y. Okay, ni ialah dia punya bentuk seterusnya. Okay, dan ini bila punca kuasa dia sama x, then we can combine ab punca kuasa x. Okay, this is the rule. Ingat tak yang previously kita ada jawab soalan tutorial yang ada punca kuasa macam ni. Okay, this is the rule that I use. Okay, so now for this example, okay, if you want to answer this, x power of 3, 5 means referring to the previous rule, this is x power 3 campur 5 iaitu 8. Dan yang ini ialah akan dapat g power of 3 kuasa 6 iaitu 3 kali 2. Dan every number yang kuasa kosong akan dapat 1, dan yang ini ialah 8 kuasa 2 by referring to the previous rule and punca kuasa 3, and we'll get this is equal to 4. And here is p power of 2 tolak 4 ialah negatif 4. Bila negatif 4 dia ialah apa? 1 per p kuasa 4. Okay, so now this is what? Okay, we look at this. This is negative. Can we change negative number to the positive? We get 81 divided by 16 power of 3 over 4. So no more negative power now. Then we solve it by, okay, so now it is 81 power of 4 punca kuasa 3 bahagi dengan 16 power of 4 punca kuasa 3, then you get 27 over 8. Okay, next is Logarithmic function. For logarithmic function, sorry. Okay. For x power greater than 0 and a is greater than 0 and not equal to 1. Okay, this is the type of logarithmic function, and this logarithmic function come from this exponential term. Okay, how can we change this to this? Okay, when we have contoh when we have 5 sama juga dengan 4 kuasa X. Okay, how can we put this, how can we represent this equation to the logarithmic equation? Then it is equal to log 4, base 4, because of this base become base also. Then 5 we put here, then it is equal to X. Okay, now this is how we change from exponential to logarithmic equation. Okay, the function of f as log a(x) is called the logarithmic function with base a, like this. Okay, this is log 10x. We can simply put log 10 as log x, and this is the common log, which is kita tak letak. Kalau kita tak letak, maksudnya kita assume that this particular of log is log 10. Okay, if you want to calculate by using our calculator, and this is the log function, and this log is log base 10. Okay, so now here for log base exponent, yang ni kan kita ada natural logarithmic ni. Okay, is ln. Ln ni ialah log asas e, iaitu kita panggil sebagai ln. Ln bukan in ln. Okay, so sekarang E yang tu ialah macam tadi yang saya cakap, E ialah satu nombor iaitu nombor E ialah 2.718228. Okay, this logarithmic function, okay, this is the graph for logarithmic function. Okay, it is actually this is the 2x just now, and logarithmic function is the inverse for this particular graph. Okay, macam ni kita lukis graph untuk inverse, ialah kita lukis satu garis y sama juga dengan x sebagai cermin, then we reflect this towards this cermin ni. Okay, so now we get this. This is the graph for logarithmic asas 2. Ini ialah 2 kuasa X. Ini ialah logarithmic asas 2. Dan now our interception just now is 0, 1, right? So now it become 1, 0 for this logarithmic function. And this is the vertical asymptote, which is y axis. And the relationship between these two is, okay, like previously I told you that this particular of y will become our power, then our a here base akan jadi base juga, and yang ni akan jadi satu keputusan x ni. Okay, so that how we convert from logarithmic to exponential. Okay, logarithmic function is inverse function of exponential function. Then this is the exponential function. Then this is the logarithmic function that equal to x is equal to a power of y. Okay, now this is the exponential form and this is the logarithmic form. Nampak tak kat situ? Yang ni base akan jadi base dekat sebelah, dan kuasa ni akan jadi keputusan dia. 8 ni akan masuk ke dalam. Macam tu juga untuk yang lain. Macam ni, kamu nampak tak? Kenapa log 5 dapat 1? Sebab 5 kuasa 1 sama juga dengan 5. Always. And y is log 3, 4, 1 sama dengan 0. Because of any number power of 0 will get 1. Okay, now logarithmic function y log ax is equivalent to x a power of y. Okay, so now this is the logarithmic function of graph. Okay, then here it's inverse, right? So it terbalik daripada exponential. So just now yang ni adalah kita punya range kan? So now our range previously will become the domain. And this is the new range for logarithmic function, which is the range is negative infinity until infinity. Okay. And this is the horizontal asymptote for this logarithmic graph. Okay, so this is the properties, which is the domain 0 until infinity, range negative infinity until infinity, and x-intercept is 1, 0, and it's continuous from 0 until infinity, and it increases when a is greater than 1, and it will decrease when a is less than 1. Okay, this is the common logarithmic function, and when we want to draw this graph, okay, we have to find number. Okay, kita tahu logarithmic A base dia X ni dia tak mungkin negatif. So A tu kita kena consider yang sekecil-kecilnya, which is yang sekecil dia tak mungkin kosong, dan kita yang ni orang ni dia ambil 0.01 dan it find the fx value ni ialah 0.1 dan this is the y value dan seterusnya, dan dia bolehlah plot. Okay, this is the log 10x graph. Okay, and this is the intersection and the logarithmic function rule, and this is the rule. This is the rule that you have to refer when you solve the logarithmic function punya question. Okay, so from this rule, okay, nampak tak kat sini A sama dengan A. Lepas tu, okay, bila kita nampak base dia sama dengan ni, kuasanya akan jadi jawapan kita. Macam tu juga dengan yang sebelah ni. Dan bila kita ada X kali dengan Y, dia ialah X log A X campur log A Y. Macam tu juga dengan bahagi. Bila dia bahagi, dia ialah tolak. That's it. That's what we call the quotient rule. And okay, when we have power y ni akan letak dekat depan y log ax. And this is how we change our base. Sebab kalau kita guna calculator, kalau kita nak cari log 5/3, kita tak boleh simply tekan calculator log 3 because of the log from your calculator is base 10. So now you have to convert it to log 10 3 divided by log 10 5 by using this rule. Okay, so example 7 now. Okay, log 6 is equal to what? 6 just now refer to the rule AA sama dengan 1. So 6 is equal to 1. Same as this. Log 3 power of 5 will become 5 based on previous rule. 7 log 9 will become 9. And this log is, okay, 8 punca kuasa. Punca kuasa ialah kuasa setengah kan? Okay, bila dia kuasa setengah letak dekat depan, which is we are referring to the power rule. Yang kuasa tu akan letak dekat depan. Okay. Always refer to the rule. Okay, kalau saya kadang-kadang saya tak tengok rule, kenapa? Sebab macam dah terhafal. Kalau kamu pun dah biasa tengok rule, nanti kamu pun terhafal juga. Maksudnya bila nak jawab, kita akan sentiasa rujuk this particular rule to get the idea to solve. Okay, so for example 8. Okay, now simplify. Okay, nampak tak kat sini? Bila ada log dan log sama dia punya base dan dia ada tambah dan tolak. Bila kita tahu tambah just now will become darab and tolak will become bahagi from the rule. Okay, now it's become log 14. And for here, which is ln E, 2, power of 2, we put it in front. Ln E will become 1. So 2 times 1 will become 2. Okay, kalau ini kalau ada tak faham, nanti masa tutorial please ask. Okay, now for this, if we want to simplify this, first we know that there is something in front of ln. Make sure there is no some number in front of logarithmic of ln function. So for this, make it power 3 power of 4, and this is 4 power of 3 like this. So after we know that this is ln and it involves minus here there subtraction, then we know that we have to combine these two become division. So now from this we know exponent power of ln will get this particular number only, which is 81 over 64. Then this is the final answer. Okay, this is the rule for natural logarithmic function. Okay, same as previous logarithmic because of ln is log also, but log power log base at e, kan? Okay, now this is the number 2 rule, and this is the inverse property rule, and this is the one-to-one property rule. Okay, same as previous. Kalau dia punya ln kat sebelah-sebelah ni sama, okay, we can simplify it become x is equal to y. Okay, simplify is expression. So now here how can we simplify this? Nampak tak? The ln e kuasa negatif 2. Okay, kita refer kat sini. Ln e kuasa x ni dia refer kat nombor 3. Dia akan dapat x tu negatif 2. So sekarang eksponen ln 20. Eksponen ln 20 dia refer dekat sini. So sekarang dia dapat 20 tu lah jawapan dia. Okay, so yang ni 3 ln eksponen. Kita refer dekat 3 ln eksponen. Okay, kita refer kat sini lah. Ln eksponen ialah 1. So 3 kali 1 ialah 3. Dan punca kuasa ln 1, ln 1. Ln 1 ialah kosong. So kita tahu nilai dalam ni kosong. Punca kuasa kosong ialah kosong by referring to this rule. Okay, now for example 9, we want to solve. Okay, if we have question like this, we can solve it by change this term into exponential term. Okay. Dan kalau kita nampak kat sini exponential term 2 kali berapa dapat 16. Dan kita tahu bahawa 2 kuasa 4 dapat 16. So y sama juga dengan 4. Macam tu juga untuk yang ini. Maksudnya 12, 1/2 kuasa berapa dapat 2. 1/2 2 kuasa berapa dapat 1/2, iaitu kita ada 2 kuasa negatif 1, y sama dengan negatif 1. Kalau macam ni ialah 4 kuasa berapa dapat 16, 4 kuasa 2. So y sama juga dengan 2. So yang ini pun 5 kuasa berapa dapat 1, 5 kuasa kosong. Jadi y kamu sama dengan kosong. Every time yang ni kalau tak tahu jawab guna log, tukar kepada exponential punya equation. Okay, this is the equality. Okay, kalau dia log B sama-sama log B, kita boleh selesaikan M sama dengan N. Begitu juga kalau B kuasa M sama dengan B kuasa N, kita boleh selesaikan dengan M sama dengan N. Kita boleh maksudnya turunkan ni dengan kiri kanan sama kan? Okay, jadi kita boleh eliminate. So we will get M sama juga dengan N. Okay, so now how can we solve this equation? Okay, kiri kanan sama kan log 6. So kita ambil yang hitam ni saja. 2x sama juga dengan x campur 3. Then we solve for x. So we'll get x sama juga dengan 3. For this equation, we have the base sama 5, 5. So we take the black term only. So we solve for x, we get x sama juga dengan negatif 1. So example 11, here kiri kanan sama base 3. So now 2x minus 5 is equal to 3x plus 3. So we take down the power and solve for x. We get x sama juga dengan 8. Okay, so this kind of question, okay, if we have this, kita kiri kanan ni tak sama tapi kita ada x sebagai kuasa dia kat situ. So how can we solve this? First is kita boleh lonkan kiri dan kanan. Bila kita lon di kiri, nanti x ni kuasa akan letak dekat depan. Okay, macam ni. Oh, pun boleh juga. Yang ini ialah orang ni dia tukar equation ni daripada bentuk exponential kepada bentuk logarithmic. Okey, maksudnya yang ni akan jadi base ni akan jadi base dia, jawapannya akan letak dalam dan x campur 3 akan letak luar. So selesaikan yang ini dan kalau ini kita akan dapat satu nombor. Boleh selesai log 47 ni boleh selesai iaitu dengan tukar dia punya base. Tukar base dia akan dapat tukar base 10. Kan? Kita akan dapat negatif 4.40368. Okay, this type of example. Okay, how can we solve x? But here we look at this by using the rule plus here when we have the same this log, we can times, right? Kita boleh darab. Okay, so sekarang dia ada satu log je. Daripada 2 log, kita dapat satu log. Okay, so now, how can we solve this? Okay, daripada yang ni, kita tahu bahawa kita boleh selesaikan yang ni menggunakan exponential term. Maksudnya kita jadikan dia, ni log ni kan log asal 10, 10 kuasa 2 sama juga dengan nilai yang dalam ni. So selesai untuk X. Dah tak ada dalam bentuk log. So kita boleh selesai untuk X. X tu ialah, selesaikan, dia akan faktorkan kat sini. Sebab persamaan kuadratik kan. So dia sama dengan 20 dan ataupun 5. Okay, this is the application of logarithmic. Okay, contohnya kat sini kita nak selesaikan, kita nak tahu berapa dia punya pressure bila weight dia 92. Okay, so now we know that our M is 19.4 and B is equal to 18. So replace this type of, maksudnya this information into the equation given. This is the equation given and this is the information that they give to you. Then just replace it first to M value and this value to the D value. So now we know that we want to find for X equal to 92. So now just replace your X here. So just press your calculator and you get the answer. Okay, so we no need to know the operation here. Maksudnya macam mana dia dapat ni, apa eksperimen dia guna, tak. Kita selesaikan dari segi matematiknya sahaja. Okay, tak ada masalah kalau dapat soalan yang panjang-panjang macam ni, sepatutnya tak ada masalah. Sebab kita dah tahu information yang kita nak dapat dan apa benda yang kamu nak cari. The second example for application problem is this. When we have R, and this is the equation, then they give you information about this and they want to know, then it state that T is in years. So now this is the carbon ratio 14 to 12, then dia nak tahu berapa umur dia, maksudnya dia ambil masa berapa lama. Okay, berapa umur dia. Okay, so sekarang kita ada information apa? R kita ada kan, so kita just put R here to the R from the equation given. So then we get this kind of equation. Now your task is to find the value of T, which is T itu ialah dia punya jangka hayat. So now just rearrange this equation. So yang ni, kita tahu yang ni kalikan, kita bawa sebelah jadi darab. Kita ini darabkan, kat darab yang ni akan kita dapat bahagi-bahagi, dia akan dapat darab 10 kuasa 12. So tinggal yang 3 kosong ni lah, 12 tolak 15 kan dapat 3 yang kosong ni. Okay, so now macam ni nak selesaikan T ni. Kita tahu bila kita nak turunkan T ni, kita boleh letak ln kiri dan kanan. Okay, you can get the T now by, okay yang ni kena letak kat depan lah. Okay, so dia akan dapat dekat sini, tapi ln dekat sini still sama. Jangan ubah apa-apa. Maksudnya dekat sini memang dia dah eliminate, you get 1. So then yang ni boleh turun, dia dapat yang ni. So yang ini, okay, how can we get negative T here? T ialah kat sini 8.22, jangan darab dekat belakang ni maksudnya jangan darab. Maksudnya kita akan darab 823 ni, darab the whole ln ni. Okay, so now it is negative time negative and it's approximate to 56796 tahun. Okay, so now it is approximate answer because of it want to get the years. Okay, kita takkan cakap perpuluhan dalam tahun. Tahun tu maksudnya menghampiri berapa. Maksudnya orang tanya kamu kan, umur kamu berapa? 18. So takkan kamu nak dapat 17.968. Takkan, sebab kita tanya umur. So approximate umur, kamu akan jawab dia dalam bentuk approximate. Okay, now end of this lecture. So I want you to ask in the forum, please ask in the forum or write something or try to solve your friend question at the forum for week 4 in order to focus for the quiz 1 next week. So that forum will represent your attendance for this week. Okay, so see you next week on tutorial class. Assalamualaikum and salam sejahtera.